Okay. Hi, everyone. Thanks for joining today from around the world. My name is Haroen. I'm Chief Technology at Luzmo. Today, we're going to talk about how you can apply artificial intelligence specifically to the field of analytics and customer-facing analytics. And we're going to start off with a quick overview of the state of the AI market, which is in full flux, as you know. And then we're going to delve into 5 specific use cases and demos that are specific to analytics and customer-facing analytics, and then give you some tools to get started applying these to your own data and applications right away. There is some time reserved at the end for questions, so feel free to send those already via the Livestorm app. For the rest, we have quite a bit of ground to cover, so I suggest that we kick off straight away. So let me start with this. I've been active now for quite a while in software development and coding for about 22 years, and I'm following AI research for about 12 years now. And the rise of generative AI over the last 18 months is really the most impressive technology breakthrough that I've witnessed so far. The GPT-4 and ChatGPT introductions really left me falling off my chair. I truly believe that this is the most important technological innovation of the century so far, and we are still at the beginning. So if you are still on the fence about whether AI is a hype or a bubble, perhaps not, as you are present here today, well, I believe that it's definitely not, and especially in our field. Generative AI really brings a technology platform shift, by which I mean a disruption in the underlying technologies that are used in our platforms and products, and really a breakthrough in what we are able to achieve computationally. For example, generative AI opens up all kinds of new use cases, but it also radically shortens development time of what was already possible before, and also makes the market for people who can build things a lot larger. So it changes the economics of what we do, but not necessarily what we do. And in that sense, it's quite similar, I think, to the rise of cloud computing, which also enabled smaller companies to realize certain use cases that before required a large amount of capital expenditure, capex, by just buying servers, online by the hour or run Lambda functions. However, AI is not yet a distribution platform shift. And what I mean with that is that generative AI has not yet changed how we consumers, office workers, knowledge workers, etc., are using computers and computation in our daily lives. For example, Google's market share, while it was expected to have happened already, they have not really diminished yet. OpenAI has a strategic play where they want you to use the ChatGPT ecosystem with custom GPTs, etc., to let you spend as much time as possible and do as many tasks as possible within their interfaces. But in the end, we're all still using Word and Excel, albeit powered by AI. So we haven't yet moved to different platforms to actually consume computation, to actually perform work. And I believe that this really offers a massive opportunity for SaaS companies to actually build useful products for clients that are AI powered. We need companies to bring this to market. AI is definitely, in my view, not going to replace software as a service as a whole, but software as a service platforms that are AI powered will have a big advantage versus peers that are behind and that are not offering the extra value that generative AI can bring to our clients. The field is really moving very, very fast, which in my view makes it quite likely that we are still in the beginning stages. The model performance has been growing almost on a daily basis, and we had just yesterday we had 3 big releases, new releases of of language models. So the performance has been improving across almost every metric. The accuracy of results based on all kinds of benchmarks on common tasks, but also the context window sizes. So the total amount of input that you can send to a model has grown tremendously. And finally, the capabilities of the models are a lot larger. They can generate code while you're working. They can process images, audio, video. They can provide also images and audio, etc. And in fact, this list that I put up here, you don't need to remember it because it's fruitless. The frontier actually got pushed a little bit farther already yesterday. So OpenAI released a new GPT-4 model turbo version on April 9th. That's again outperforming the top one in the list here, Claude 3 Opus. And that one was only released a month ago. So even without big retrainings and a new generation of models, we're still seeing a lot of improvements going on. Now, good for us. I believe that this doesn't really matter much ultimately for SaaS companies and product leaders. Why? Because of the API-first economy. So the interfaces of all of the models are very similar. There are even middleware layers where you can just swap in or swap out a model very easily. And also the capabilities of the models are converging. So you are seeing function calling, so the ability to call into APIs. You see that appearing in all of the models now. And this means that use cases, this is a small first prediction, but it means that use cases that are not feasible today might actually, or even have a high likelihood of being possible tomorrow. The model training, however, is very expensive, and we'll get to that in a second. There's probably room for 1, 2, or 3 new big model generations before we start getting into the territory where additional training is just too expensive, where it becomes the cost of percentage points of the entire GDP of the US, for example. But still, we see that the performance of the models is really dominated by the compute power that is used to train them, and not by the training data that goes into them. For example, Bloomberg fine-tuned a GPT-3 model specifically on all the economical data that they have, and that one outperformed a native GPT-3 model, but GPT-4 beats it on every metric, even though it's not been specifically trained on economical data. So it means that the best generalist model at the moment just beats specialized models, even in their own specialty, which means that we don't really have to care. We just have to, build new applications or applications that are perhaps not even feasible today. We can already build them and just swap out the APIs. So we are big believers in API first. Small second prediction is that big players like Microsoft, Meta, and then Google and Amazon, etc., that they are really dominant and will remain dominant in AI. And there are several bottlenecks that cause this. And one of the most important ones is really a crunch in the supply chain. So the number of GPUs, especially NVIDIA H100 and the new H200 GPUs, they are essentially the only ones that are economically viable to train on today. And other GPUs just take too long and just are too costly to run. And the production is going to quadruple this year. It is expected from 500,000 to 2 million GPUs produced this year, but it's still not enough. And you can actually see that the large players take up a very large percentage of the total volume of the available GPU supply. So especially Microsoft and Meta, they alone took up about 300,000 NVIDIA GPUs last year. Even though that the relative training costs are decreasing a lot, so they're down by 70% per year because of hardware improvement, but also more efficient training. still the costs are ballooning. So they are going from about $10 million estimated for GPT-3 to $100 million plus for GPT-4. The next model, GPT-5, might be at the 1 billion range. And finally, a big bottleneck is the training data. There's really not enough human written content anymore to actually train these models, where the internet is also tainted now with lots of LLM generated content. Might be the majority of new content actually already today. So real human content is becoming rare, like steel produced before the nuclear atmospheric tests. Now, luckily, the different models are fairly interchangeable. And there's also a variety of business models. So you have OpenAI, who, of course, provides AI as a service. But Meta, for example, releases their models as, currently at least, as open weights. So you can run them yourself on your own hardware or in the cloud. And thus the price of using LLMs is also under pressure and is driven down to the marginal cost. So it could actually be others in the value chain of AI who are able to capture most of the value that AI is bringing. For example, the chip producers, they're of course one of the people who stand to gain the most at the moment, with NVIDIA as one of the main benefactors there, but also SaaS vendors, because if they can translate the technology shift into actual new value for clients, it's well possible that they actually capture a large part of the extra value that is created, just because of the downwards competitive pressure on the price of the LLMs themselves. Final prediction: we are going to see more and more agent workflows, so AI agents. And the reason for that is that large language models, at least today, they are forward-thinking only. So each new token, part of a word that is predicted as the next likely word, it depends only on the input prompt and the text that has already been generated before. So it's like it needs to write a thesis or an essay from front to end without ever editing a word that came before. And that means that a language model has a limited capability of planning and reflecting on what it has already done. So this is the reason why what's called chain of thought prompting, so where you ask the LLM to first write an outline and then flesh out each of these individual parts, typically gives you better results than just asking for a result and expecting the model to come up without an example with a perfect answer. And an AI agent is another way, or a way to force this. So it's a kind of self-contained piece of software that receives a problem, like a prompt today, and that then can iteratively interact with the language model itself. But it can also store previous replies, and it has access to external tools, like doing web lookups, calling into external APIs, like translation APIs or Luzmo API, and doing generally computations beyond the language model itself. Okay, now after that short market state, let's look at ways how the current generation of generative AI models can really help us in customer-facing analytics. So, for example, in automating menial tasks, in speeding up the development of customer-facing analytics tools, and thus also increase or decrease the time to market, or just open up new possibilities of things that are not possible yet. And so one of the main straightforward uses of AI in analytics is just to ask for the insights that you're looking for directly. So asking which products are most popular in Q1, which markets generated the most revenue in the last 18 months. And with the feature Ask AI that we released recently, you can do exactly that. You can ask for a question, and charts are generated based on your prompt and the data sets that are available in your account. So if you haven't tried that out, definitely do so. We're also big believers, as I said, in the API economy and in API first. So we've also made this feature, the AI chart generator, available via API. So you can actually embedded also within your own platform. For example, as a capability of your own chatbot that perhaps already can do certain transactions within your platform, but can then also answer with a chart, for example, that is generated through the Luzmo API. More on the demo side now. So going beyond that, as you know, large language models are very capable of extracting information out of unstructured datasets, and that is a typical time sink when setting up analytics applications. Very often, even datasets that contain unstructured data are just not considered at all during building a customer-facing analytics app, as it's deemed too difficult to do something with the data. Now, LLMs can easily help there, and let's dive into a little demo here. So for all the demos here, I'm using 𝗪𝗵𝗹. You can use, of course, different models, and apologies on beforehand if one of the demos fails because of an outage. So a lot of interesting data is locked up, embedded within unstructured data. So let's say that we want to analyze the most recent inflation data. And actually, the American government just released new inflation data about an hour ago, and we want to do something with this. So instead of having to do manual transformation work, we can just ask something like this. So we are going to extract the CPI data in table A on this web page, and then return it as a CSV snippet. Now, if we ask this, GPT-4 can access the web and can actually go into that page. I can also show it. It's open here. So it's a text-based document. You could also download a PDF and upload that one. You see that there's some structured data here embedded that takes some work to extract with the CPI, so the inflation number for various categories over the last few months. And so you see that ChatGPT can extract this one. I'm going to give it a little while, or we can come back to this in a second. But you can easily copy paste this one, save it as a CSV, and then upload it to your Luzmo account, for example, to start analyzing and visualizing it. Another example is that you can, for example, analyze unstructured text data. For example, a lot of SaaS companies will be using a CRM system, and it will contain probably a lot of information on the conversation history that has happened with your clients. And so an interesting way to do something interesting with the data and derive insights from it is to download that information and then use a language model to analyze the different interactions and come up with, for example, churn reasons that are embedded in those. And here the agent model and the iterative prompting approach really works well, because just putting in all interactions of all clients makes it quite difficult for an LLM to come up with accurate churn reasons. Also because LLMs are not very strong in mathematics and doing an analysis themselves. But what you can do is, for example, download all of the conversations in a CRM system, for example, HubSpot, via API or export, then send all of those individually to a cheap language model like GPT 3.5 to create a summary of the reasons why a particular customer has churned based on the interaction that you had with them. So not just the churn notification that you might have received, but also other interactions before that, which might also have predicted an upcoming churn. Now, from those summaries, we want to create a kind of churn classifications. And so from all the churn summaries that we have received, we're going to send those again to ChatGPT and ask for a classification to put each of those in a hierarchical bucket of churn reasons. For example, the support might be slow, and that might be caused by a back and forth of answers, or no answer being provided at all within a certain amount of time, or the answer that was being provided not being sufficiently good enough to actually answer the question. Now, from that, we can create a structured data set, then upload that to Luzmo and analyze it further. And you can do this with all kinds of data. You can easily envision this being used, for example, to process online product reviews, to get out certain keywords that are important, and classifying the number of posts that fall into these buckets, or doing social media sentiment categorization. That goes a little bit further than the old demos where you can have a positive or a negative sentiment, but extract really problem areas with your product. A third use case is the following. So LLMs are very capable in assisting in the creation of synthetic data sets, so demo data sets that can, for example, be used for building sales demos or doing benchmarking. And in the meantime, our CPI data has been processed. So what you can do here, for example, is to just ask for synthetic data directly. So if we are interested in creating a synthetic data set of 100 rows, for example, the example we're going to use here is to generate fitness data. So imagine that you have several users, and they each wear a wearable fitness band that generates some data, and we want to analyze that. But before actually putting in the work of getting that set, we want to have a demo set to already start building a dashboard today, and pitch it and see if this might be an interesting alley to further explore. So we're going to create a synthetic data set of 100 rows of fitness tracker data. 1 row per day per user, and we're going to include at least the name, socio-demo information, and step counts, and also an average heart rate. And we're going to ask it to be creative in choosing names and columns in order to avoid us ending up with data sets like user 1, user 2, user 3, etc. So what GPT is, or ChatGPT is actually doing here in the background, is generating a Python script that it will then execute to give me the data set as a CSV file. This is a good way to do it for smaller data sets, but it takes a lot of time. And it's also a relatively costly query if you would automate this via the API, because of the high number of output tokens and the high number of processing time that's needed to generate this, because all of the work is now done by ChatGPT. So let's give it some further time to finish this. Okay. Voilà. So now it has run this. So it has added a city, gender, age, our names, average heart rate, and steps. So a number of columns that were requested, and also a number of columns that it kind of creatively added to the set that might be useful for analysis. And we get our first few entries from the set, and I can ask it to expand it to a full set, download it, then start using it as a demo set, and a lot of time saved. Now, there is a different and cheaper way to do this, which is especially important if you want to generate demo data at scale, because 100 rows, let's be honest, that's not really impressive for a BI tool. And a good way to do that is by using the LLM to actually be the brain that decides on what kind of data we want to generate, and also what kind of constraints we want to give on the information, but then use a second, faster library for the actual data generation. So for example, we're going to, describe a synthetic data set instead of generate a data set, again, of fitness tracker data in JSON. and we want that to be structured as an array of different columns. So we want, for example, a name. We want it to be text, and we want to have different example values. So I'm going to take myself, Mika, who kindly organized this webinar, and Frederick, one of my colleagues. And then I want a different column, for example, that is going to be a country, or let's take a different example here with a different type, where I want to generate some numeric data. And I'm going to set a minimum. So I want prices between €0 and €100, for example. Voila. And what is now going to happen is that instead of generating a set for me, it's going to generate the description of a set for me. So I have age with minimum and maximum between 18 and 65, different genders, different cities, different random names, etc. And I can use a library like faker.js, which is a library that can actually generate random data, but that one needs constraints to actually generate something useful for me. So we are going to couple these two together to generate a new set for me. Another interesting use case is to enrich your data with open data. So open source intelligence, OSINT. And some examples here are translation of data sets, which is also a menial task that often happens, but also enrichment of data sets. So what I can do here, again, it's very easy. If we go back to my CPI set, I can just ask this to translate this. So translate the CPI data set to Dutch. And my set is translated in Dutch, and I can use it. Of course, I can also set up all of these examples via the API of OpenAI and Luzmo, for example, in order to automate many of these tasks. Another example is to do geocoding. So what I'm going to do here is I have a data set, let me see, with landmarks. So different important buildings around the world. But in order to put these on a map, I'm missing the coordinates to actually put them in. So geocoding. So given the sets, I'm going to, I want to enrich it with extra columns, like latitude and longitude, using a free geocoding service. Respond with the enriched CSV sets. Okay. So what format is the data in? Wait, I'm going to copy paste the set for a second instead. Voila. It would be interesting if it now actually did what I asked. That's the risk of demos, of course. I'm going to switch here. So I did this just before the demo and ended up with this geocoded example where it actually enriched this set for me with geocoding, and I can upload it easily to my Luzmo account. See webinar, and we have our geocoded data. Something that typically takes quite a bit of time to get right. And I can add my coordinates data here, latitude, longitude, and build a dashboard with a symbol map, for example, that puts in the coordinates. And you see that I have all of these landmarks around the world. What I still need to do is to set up a quick topography label on my landmarks and refresh this. And now I see that, you know, the Notre-Dame, the Palais de Versailles, the rijksmuseum, Buckingham Palace, etc. are all on my map. So we saved quite a bit of time here. Okay, finally, we have an interesting use case that's just creating an entire dashboard from scratch using vision APIs. So a tool that we recently launched, which is called Instachart, and you can use this yourself. It's at instach.art, where you can actually generate a dashboard from scratch by just using a sketch of a dashboard or a Figma mockup, or even some text that describes the dashboard. I'm just going to demo this for you. So I've drawn up this dashboard just before for our demo with a drop down here with burritos, a date, and then a bar chart, the sales over time of a fictional burrito store, and then the type of burrito, beef, chicken, etc. that was generated. What I can do is just hold this before the webcam, generate a dashboard, and I'll wait a little bit before a combination of GPT-4 vision and the Luzmo API actually creates this and turns this into a fully functional dashboard, including demo data. So the demo data is also generated behind the scenes using actually the Faker.js approach that I just talked about to generate this. So we have our burrito size, medium, outrageous, small, the different sales by size, sales over time by week, sales by filling. And the data behind this is auto-generated. I can also click on any of these charts or use any of these filters, and the dashboard is actually interactive. So it's slicing and dicing like a regular Luzmo dashboard would. So you can save quite a bit of time building out new, new designs for dashboards or uploading your Figma mockups to turn them into working dashboards. Just to give you an example here. So this is another example, and you see here that I just have an image with some text, an insightful and visually pleasing dashboard related to takeaway burrito production facility quality. And I'm just going to upload that into the tool and generate a dashboard based out of that. Bear with us for a second. Okay, it also shows you what others did. So my my example just before ended up with this. So it generated again demo data sets, including temperature, humidity levels, quality rating, perceived quality rating, and different ingredients, even coming up with creative ingredients like guacamole, salsa, etc., that were not present in the input data. And creating a dashboard out of this that you can use, and then you can edit this actually in Luzmo to put in your own data and use it as a starting point for a new dashboard that may end up in production for customers. Okay, back to here. So that were 5 use cases of how you can use AI really today in analytics, in customer-facing analytics, to start speeding up tasks or make new things possible. And we've included a number of resources here in these slides to get started. So there are various blog posts that explain how we did this, or even share the code. You can also, of course, try out Instachart. That one is publicly available to get started. Thanks for listening. Are there any questions that we can answer for you? Instachart is indeed a free tool at the moment, so you don't even need a Luzmo account to use it. But the dashboards that are generated are public, so others can see what other people build at the moment, and then you can edit the data in Luzmo, and from that moment onwards, you're working on a private version of the dashboard. So the dashboard is copied to your account or a new account that you create, and you can get started editing that. So data that you upload is through Instachart that is not available. So that's why we always generate demo data based on the screenshots that you upload. But you can upload private data in Luzmo itself, and that of course is not public. You can upload data safely there, and that will only be visible to your own users, and you have lots of sharing options, etc., to control who can see this. So Instachart is available at ch.art. So indeed, the use cases I gave are very general for customer-facing analytics. Luzmo adds value in several ways. So first of all, we have this API-first approach that makes it very easy to integrate with large language models. And that means that if a model comes out like GPT-4 Turbo that was released yesterday, you can immediately start using that. You don't need to wait on us to add this. And this is what we see with some other players in the market. They have a very closed ecosystem where everything that you do with the dashboards needs to be built by them, which causes them to innovate relatively slowly. While the dashboards here, our dashboards are described by a JSON format that's also publicly documented, so you can use any kind of code to auto-generate them. Of course, you can also drag and drop them in the interface. So you have more entry points, which gives you more options. Now, we also know that not everyone will be building their own integrations on top of Luzmo, and that's why we're also adding AI features natively to the platform, like the Ask AI prompt that's just within the product and that you can use without any integration work, or AI suggestions, where based on the dashboard that you have already created and the data sets that you're using, where the new charts are being suggested that might be interesting for you to add to the dashboard. And those are in a drop-down list. You can just click them and add them to the page. Does that answer your question a bit, Ram? Great. We don't have specific AI webinars on the planning, but if this one was interesting for you, we can of course look into holding them more regularly and going into deeper and deeper or more advanced use cases, because this is, of course, there's opportunities everywhere. I believe. Thank you, Julian. So no, the Luzmo API, the Luzmo API is free to use. At least it's included in every plan, every pricing plan that we offer. And indeed, there is a JSON schema that describes how the dashboard definition language, that specific JSON should look like. Actually, the developer documentation was renewed today, so you can use that as a start. Leonard, what do you specifically mean with this? I think that so I think there are various options or ways to get started with this that at varying levels of skills. So if you have no programming skills at all, then you can just use our drag and drop editor to create dashboards and add charts to the page. You can use Instachart and just draw a mockup in another tool or just on a piece of paper and scan that to get started. For GPT also makes it quite easy to get started with data transformation and basic data analysis. If you come up with some prompts to do this, and that was part of the goal of today, to give you some inspiration of what is possible with these tools, even without technical or coding knowledge. If you have the ability to code, you can also go further and set up API integrations between Luzmo and various language models. And our blog contains some examples of this. So we have, for example, the example of deriving data from HubSpot, then analyzing it, categorizing it, and uploading that to Luzmo as an end-to-end chain that's fully automated on our blog. So the links to that are on here. So the unstructured data example churn analysis here will link you to the blog, and the slides, of course, will be shared after this session. Okay, if there are no more questions, then thanks for attending, and hope to see you on one of our next events. And if you have any further questions, please just contact us, and we'll be happy to help you out building your tool. Thanks for attending. Bye-bye.